Good day, good evening, everyone. It's me, Raven. Uh, in this video, I'll discuss the graphs, then the flow of the code, and yeah, and what is graphs. So let's start. So introduction to graph theory. So in the domain of uh, mathematics and computer science, graph theory is the study of graphs that concerned with the relation among edge and vertices. So it is the popular subject having its application in computer science and information technology, biosciences, mathematics, and linguistics, to name a few. Without further ado, let's start finding a graph. So this is the uh, our example of graph. So, so what is graph? So what is graph? A graph is a pictorial representation of a set of objects where some appears of objects are connected by links. So the interconnected objects are represented uh, by points termed as vertices, uh, and the links that connect the vertices are called edges. So ang vertices, which is ani as example in here in our example. So A, B, C, D, which is our V or vertices A, B, C, D, E. Then E is our edges, which is AB. This is a edge AB. Then AC. Then uh, BD, CD, and DE. This is our edges. Application of graph of theory. So the graph theory is the application of diverse field of engineering. Electrical engineering is a concept of the graph theory is used to the circuit connection. So computer science graph theory is used to a study of algorithms. For example, Prostak algorithm, Prince algorithm, and Distrust algorithm. Computer network. The relationship among interconnected computer in the network follows the principle of the theory. So science, the molecular structure of chemical structure of a substance, the DNA structure of an organisms, etc., are represented by graphs. So linguistic is a parsing tree of a language, and a grammar without language uses graphs. So routes between the cities can be represented by using graphs. So a graph is a diagram that points into a line connected by the points. So one graph. So this is that's a graph. So it is has at least one line, um, set of two vertices with no vertex connecting itself. So the concept of graph is graph theory translated as on some basic terms such as a point, line, vertex rather, edge, degree of vertices, properties and graphs, etc. So here in the chapter will be a fundamentals of graph theory. So Point is a particular position of one-dimensional or two-dimensional or three-dimensional space. For a better understanding, a point can be denoted by alphabet. It can be represented with a uh, dot. So example, so dot which is ang which is our dot is represent for A. So line is a connect between 2 points. It can be represented with a solid line. So this is A, and B connect with connect between 2 points. So which is here the point A and the point B is connect between two. Here, A, B are the points. The link between the points of called a line. So vertex is uh, where multiple lines meet, and also called a node. Similar points of vertices also denoted by an alphabet rather. So edge is the mathematical term that for a line that connects two vertices. Many edges can be formed from a single vertex. Without a vertex, an edge cannot be formed. There must be a starting vertices and a ending vertices and edge. So example, so this is a B, this is edge, and this is an edge. So graph A G is defined for whereas V is all vertices E in a set of edge and the graphs. So example, so A connect to B, B connect to D connect to C connect to A. So loop is a graph is an edge is drawn to the vertex or to itself. It's called loop. So this is called a loop. This is the dot. Then this is the vertices that um um are pointing by itself. A graph is a edge is drawn from the vertex itself. It's called a loop. So it's a vertex. So um drawn from vertex so to itself. And the above graph V is a vertex if for which of the angle of VV forming a loop. Example, so in above V is a vertex which is has an edge VV from loop. So I have a code here. This is the code. So and run it. This is the output. So this graph, this this graph, um, this class represent an undirected graph. So private and vertices. So means to declare an variable vertices to store the number of vertices in the graph. So then print private linkless integer add list or adjust list means is declare an array which is our adjust list or uh, adjacent yes, adjacent list, or edge list, and of a linked list to store adjacent list for each vertices. So graphs int v, so means to this is our constructor that initialized by count v, initialized by graph, and the given number of vertices is count v, which is this count v. So in and initialize it initialize that the adjust list array and creates a linked list of linked list for each vertices. So so the void add new edge int v int w, so means to um void add new edge int v int w means to uh, add an edge between vertices v and w, v and w. So by appending w, the of by depending the one w to the adjacent less of v. So node 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 um, excuse me, node visit visited node array is equal to new boolean vertices. So means to add a new node, then add a new node, which is boolean, then um and creates an edge between new node and existing node. So and then um inside in the main, no, in our main, so we have a instantiation. This is instantiation. This is our instantiation graph. Graph is equal to new graph, then initialize uh, the our graph have a value and count v, or the versus vert, vertices 10. So then then trigger here to our constructor, which is this graph triggered here. Then this two uh, add new node edge to 5. So v, our vertices is 2 3 2 3 1 2 4 6 5 1 6 3 7 3 7. Then our side is 552 20 552 4 1 2 6 6 3 1 3 7 5. So system out dot print ln. So breadth first transversal sequence is so 2 graph transversal BFS. So 2, the output is 254631. So I hope you like my discussion today. Thank you.